Now, for the rational function, it's a function in the form of f of x is equal to p of x over q of x, where p of x and q of x are both polynomials, and q of x is not a zero function. Correction, it should be q of x. Okay? Now, so always remember, should not be a zero function. Q of x should not be a zero function because this will be undefined. Okay? So when it comes to rational function, we should be familiar with the different properties that we need to identify, such as the domain, the range of the function, the zeros, of course, which is the same with the x-intercepts. Okay, and also with the y-intercepts of the rational function. And then for the vertical and horizontal asymptote, the line x equals a is a vertical asymptote of the graph of f if f of x is approaching infinity, or it is approaching negative infinity as x approach a, either from right or left. The line y is equal to b is a horizontal asymptote of the graph of the function if f of x approach b as x approaches infinity or negative infinity. Now, so what's our rule when it comes to vertical and horizontal asymptote? So if we're going to find the vertical asymptotes, all we need to do is to look at the denominator of the given rational function and find the zeros of it. Okay? And then for the horizontal asymptote, we have three cases here. So we compare the degree of the numerator and the denominator. Okay, so if n is less than m, the graph of f has the line y is equal to 0 as the horizontal asymptote. Okay, if the degree of the numerator is less than the degree of the denominator, then we have y is equal to 0 or x-axis as our horizontal asymptote. If the degree of the numerator and the denominator is equal, then the graph of f has the line y is equal to a over b as the horizontal asymptote, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. Then lastly, if n is greater than m, the graph of the function has no horizontal asymptote. So if the degree of the numerator is higher than the degree of the denominator, then there is no horizontal asymptote. Now let's try. We have here a function y is equal to x plus 1 over x minus 1. So here, first let's try to identify the critical values here of both numerator and denominator. In this case, we have 1 and negative 1 that we will use later for our sign table. And then aside from that, we have the intercepts here. So x-intercept when y is equal to 0. So if we substitute y is equal to 0, we'll obtain negative 1. Okay, so negative 1 comma 0 as our x-intercept. And then for the y-intercept, we let x be equal to 0. Okay, so 0 plus 1 over 0 minus 1, that is negative 1. So the y-intercept here is 0 comma negative 1. And the next one for the vertical asymptote and the horizontal asymptote. So for the vertical asymptote, let's look at the denominator. So as you can see here, x minus 1. So we equate it by 0, so x is equal to 0. So x is equal to 1 rather. Okay, so our vertical asymptote here is x equals 1. And then for the horizontal asymptote, so as you can see here, let's check the degree of both the numerator and the denominator. In this case, they have the same degree, which is 1. So let's have the numerical coefficient here of the x, which is 1 for the numerator, and then the denominator, which is also 1. So 1 over 1 is 1. So y is equal to 1. Our horizontal asymptote is y equals to 1, and our vertical asymptote is x equals to 1. Okay, so going back to the critical values that I have said earlier, we will use that in our sign table here. So which are negative 1 and 1. So as you can see here, negative 1 and 1, we have two critical values. So therefore, we have three uh, inequalities here, which are x is less than negative 1, x is between negative 1 and then x is greater than 1. So here we have factor x plus 1. We know that x plus 1 will be 0 if x is equal to negative 1. And then x minus 1 if x is equal to 1. Okay? So remember the rule? All the signs here in the left of 0 is negative if the sign is of x is positive. So in this case, we have negative. And then for the right, it's positive. Same as with the second one, since x is positive here, all in the left is negative and in the right is positive. Okay, so multiply each column. Negative times negative is positive. Positive times negative is negative. Positive times positive is positive. Okay, now what does it mean when it comes to the graph of rational function? Always remember, if it is positive, it is above the x-axis. Okay, always remember that, above the x-axis. And then if it is negative, it is below the x-axis. Okay, so let's see. Let's graph that. So as you can see here, if we use the sign table, x is less than negative 1, it is above the x-axis. Okay, so as you can see, it's above the x-axis. While between negative 1 and 1, it's below the x-axis. Okay, and also as you can see here, we have the intercepts, negative 1 comma 0 and 0 comma negative 1. And then we have our asymptotes, x equals 1 as our vertical asymptote, and then y equals 1 as our horizontal asymptote. Then, last one, x is greater than 1 above the x-axis. So as you can see here, we have the graph of this function x plus 1 over x minus 1. Now, how about the domain and range? So, as you remember, if we're about to identify the domain and range, we'll just look from left to right and from bottom to up. Okay, for the domain from left to right, so as you can see, the only value of x that is not included is the vertical asymptote, which is 1. Okay, and then for the range, as you can see, from bottom to top, so as you can see, the only value of y that is not included here is the horizontal asymptote, okay, which is 1. 1. So in this case, the domain and range, okay, all real numbers except 1. Another example, we have here the function 4x over x squared minus 25. So as you can see here, let's identify the intercepts. So if y is equal to 0, then x is equal to 0. Okay, so that's 0 comma 0. If x is equal to 0, then y is equal to 0. So 0 comma 0. Okay, so our intercept here is 0 comma 0 at the origin. Okay, well, for the vertical asymptote, so as you can see here, uh, by looking at the denominator, we have here x squared minus 25, which is difference of two squares. So there are two factors, x minus 5 and x plus 5. So therefore, there are two vertical asymptotes, which are x is equal to negative 5 and x is equal to 5. Okay? And then for the horizontal asymptote, so as you can see here, comparing the degree of the numerator and the denominator is higher than the numerator. So in this case, the horizontal asymptote is y is equal to 0 or the x-axis. And then for the vertical asymptote, again, x is equal to positive and negative 5. Okay? And then for the sign table here, we use again the critical values. So in this case, we have three critical values, which are uh, negative 5, 0, and 5. Okay, so again, if you look at the numerator, for x is equal to 0, so that's 0. And then for x squared minus 25, the values of x here are negative 5 and 5. Okay, so always remember, for you to identify which is which is first among the three, always remember it's imagine the number line. Okay, imagine the number line from left to right, so that's negative 5, 0, and 5. Okay, so we have three critical values, therefore we have four inequalities here. Okay, so in this case, again, let's put 0. Okay, so remember, we have our rule here. Since all the values of x here, or all the sign of x here is positive, therefore all the signs on the left of 0 is negative, and then for the right, that's positive. Okay, so always remember that rule. That's very important. Now, let's simplify this. Let's multiply. So as you can see here, for the inequality x is less than negative 5, that's negative. And then for the inequality between negative 5 to 0, that's positive. And then between 0 and 5, that's negative. And x is greater than 5, that's positive. Okay, so again, the meaning of negative is below the x-axis. And then for the positive, it's above the x-axis. Always remember that. So let's try to graph now. So as you can see here, we have x is less than negative 5, so it's below. Okay, below the x-axis. And then x is between negative 5 to 0, that's above the x-axis. And then between 0 and 5, again below the x-axis. And then for the last one, greater than 5, that's above the x-axis. Always remember, as you can see here, the behavior of the graph, it always approaches the asymptotes. Okay, in this case, the asymptotes here are x equals negative 5, and x equals 5. Okay, and then we also have the horizontal asymptote as our y equals 0. Okay, now what about the domain and range? So in this case, again, from left to right, there are two values that are not included, which are negative 5 and 5, are vertical asymptotes. While looking from bottom to top, as you can see here, all are included. Okay, because as you can see here, we have our intercept here in our origin, 0, 0. So if you recall, our horizontal asymptote is y is equal to 0. But as you can see, there's a point here, so it's included. Therefore, the range here is y such that y is an element of all real number. Then another example here, we have x squared minus x minus 20 over x squared minus 16. So here in this case, we need to simplify both the numerator and the denominator. So let's factor. So the factors are x minus 5 times x plus 4 over x plus 4 times x minus 4. So as you observe here, there's a common factor on the numerator and the denominator. Okay, so let's simplify. So we have now here y is equal to x minus 5 over x minus 4. Okay, so what does it mean? So syempre, let's find the intercepts here. So if y is equal to 0, then x is equal to 5. Okay, so we have here x-intercept 5, 0. If x is equal to 0, we'll identify the y-intercept. So that is 0 minus 5 over 0 minus 4. That's 5 over 4. So 0, 5 over 4. And then for the horizontal asymptote, same degree as you can see here. So looking at this, degree of 1, degree of 1. So get the numerical coefficient. So as you can see here, we have 1 over 1. So y is equal to 1. Okay? Now, how about x plus 4? What does it mean? Since we cancel it, it means that this is the whole of the graph. Okay? So always remember, this is the whole of the graph. Okay? So in this case, x plus 4, we equate it to 0, so x is equal to negative 4. We have here the whole x equals negative 4. Okay, so to identify the y coordinate for this whole, let's substitute here in the simplified function. So as you can see here, if we substitute negative 4 minus 5, that's negative 9, over negative 4 minus 4, that's negative 8. Negative 9 over negative 8, that is 9 over 8. Okay, therefore the whole here is negative 4 comma 9 over 8. Okay, and then for the vertical asymptote, as you can see here, we only have one, which is x minus 4 is equal to 0, so that's x equals 4. Now, let's have the sign table. So as you can see here, we have x minus 5 over x minus 4. So equating it to 0, both the numerator and denominator, we have two critical values, which are 4 and 5. Okay, so let's have the sign table. So since two critical values, three inequalities here. And then again, we put zeros. X minus 4, that's 4. And then x minus 5, that's 0. Same rule again. Since the sign of x is positive, so all in the left is negative, and in the right is positive. Okay, it's correction. Correction. It should be positive here, and then here is negative. Okay, so again, it should be positive here, and then here, it should be negative. Okay? Nonetheless, if we multiply that, still negative. Okay, so negative times negative, that's positive. But again, correct that. So that's negative. Positive times positive, that's positive. So again, positive means above the x-axis. Negative means below the x-axis. Okay, so now let's try to graph this one. So as you can see here, x is less than 4, that's above the x-axis. Okay, so we have here our intercepts 0, 5 over 4 or 0, 1.25, and the whole. Okay, negative 4, 9 over 8. Okay, and then we have our asymptotes here and here. And then for x is between 4 and 5, that's below the x-axis. Okay, so as you can see here, it approaches the asymptote, and then x is greater than 5, it's above the x-axis. So this is the graph of this function. Okay, so now, what about the domain and range? So always remember, we are not including the asymptotes, and at the same time, in this function, let's not include also the whole. Okay, let's not include also the whole. So in this case, the domain, all real numbers except positive and negative 4. Okay, so negative 4 for the whole, and then 4 as our vertical asymptote. And then for the range, 1, which is the horizontal asymptote, and then 9 over 8, which is our whole. Okay, so all reals except 1 and 9 over 8. Okay, let's have this last example. What about this one? So as you can see here, we need to identify again the intercepts and then the asymptotes. So in this case, if we'll let x be equal to 0 and we let y be equal to 0, so we have x-intercept So y is equal to 0. So x squared minus 2x minus 3. And then we have the values of x here now as negative 1 comma 0 and then 3 comma 0. And then for the y-intercept, we let x be equal to 0. If we let x be equal to 0, then y is equal to 3. Okay, so 0 comma 3. Okay, and then for the asymptotes, we have for the vertical asymptote, we have here x minus 1 is equal to 0, so that's x equals 1. While for the horizontal asymptote, so as you can see here, there's none. Why? The degree of the numerator is higher than the degree of the denominator. So in this case, we need to divide this to identify another asymptote, which is called as the oblique asymptote. Okay, so we need to identify the quotient of this to get our oblique asymptote. Okay, so dividing it using the long division or the synthetic division will obtain x minus 1 minus 4 over x minus 1. So as you can see here, all we need to get here is the quotient. Okay, don't include the remainder. So just the quotient. So oblique asymptote is slant asymptote, which means it's not just a constant uh, function. Okay, to be our asymptote. Okay, it's linear. Okay, linear as our oblique asymptote. So x minus 1, that's our oblique asymptote. Then for the next one, again, the sine table, we have here three critical values. So for the denominator, that's 1. And then for the numerator, if we get the values of x here, we have negative 1 and 3. Okay, so again, we need to put our critical values based on the number line, increasing. Okay, so three critical values, 4 inequalities. So we can represent it through interval notation. So as you can see here, it can be x is less than negative 1 or negative 1 comma negative infinity, negative infinity comma negative 1. And then for this one, between negative 1 and 1, it's parentheses, negative 1 comma 1. And then here, 1 comma 3. They are not included, of course. And then 3 comma positive infinity, or x is greater than 3. So as you can see, you can use interval notation too when it comes to the sine table. Okay, so same rule again. Let's put 0 on each factor here. And then same rule, left all is minus, and in right all is plus, positive. Okay, so again, we simplify this, we multiply, each column will obtain negative, then we have here positive, we have negative, and then positive. Again, negative means below x-axis and positive means above the x-axis. Okay, now let's try to graph. So as you can see here, we have the oblique asymptote x minus 1. Okay, y is equal to x minus 1. And then for our vertical asymptote, that's x equals 1. Okay, and then our intercepts here, 0, 3, negative 1, 0, and 3, 0. Okay, and then we have negative infinity, negative 1, or x is less than negative 1, that's below x-axis. So as you can see here, it approaches our oblique asymptote. And then from negative 1 to 1 above the x-axis, it approaches our vertical asymptote. 1, 3 below the x-axis, approaching the vertical asymptote. And then 3, positive infinity above the x-axis, approaching the oblique asymptote. Okay, so as you can see here, if we look from left to right, The only value of x that is not included here in our graph is our vertical asymptote, which is 1. Okay? And then for our range, if we look from bottom to top, so as you can see here, it approaches from negative infinity to positive infinity. Okay, there's no exempted value here. So therefore, our range here is all real numbers. Okay, so y such that y is an element of all real numbers.